Okay, what is this? What am I working on? Why did someone give this to me? The world might never know. Let's work. Let's do it. Yeah. Panic. Can I show just by squaring both sides? Can I move something over? Can I just square both sides repeatedly, please? Please? Let's just square both sides, okay? So we're going to move x squared, and we're going to move that. Oh, see, the problem is I'm really bad at taking derivatives, so I don't trust myself to take derivatives. Anyways, this thing is definitely less. This is at most 1, so we can square both sides, no problem. And x squared plus y squared plus 6 plus 2 square root x squared plus 3 y squared plus 3 is supposed to be at least 9 plus xy minus 12 square root xy plus 3 is what we want. And now let's move things around. So x squared plus, this should be at least 3 plus, wait, something's wrong. Did I mess up already? I probably messed up already. This doesn't look true at all. Okay, what did I mess up? So something's wrong because okay, what did I do and why is it so lopsided? I flipped the sign somewhere. I just don't see where yet. Oh, I see. Okay, when 6 squared is 36, so this is a 39. I was like, why is it so far off? Okay, 39, 33 plus xy. That seems pretty weak. I feel like I should just be able to run it over, right? Like this looks like the right hand side looks like about as weak as you can possibly get, or something, or maybe not. 33 might not be that small. Let's see. 24, 24. Now let me clean things up a tiny bit. I will add 2xy to both sides so that I can get rid of that fat x squared plus y squared blob. 33 plus 3xy, and then it's like 4, so I want 29 plus 3xy. Well, I haven't applied any inequalities yet, so like everything's if and only if so far. So this has to be true. Although, actually, okay, I take back what I said. This doesn't look that bad. Because this term is actually pretty this term's pretty weak as well, actually. Okay. I could just square both sides so I guarantee that I solve the problem. That seems really unfortunate, though. I would like to be a little bit economical so that this isn't just a completely mindless calculation. Also, it looks like Hochi. Just saying. Okay, so this is like a lot bigger than... If I write this as 12, 4xy plus 12 on the inside, is that better? So then they're both like 16, so I can actually compare them. Wait, actually, so, okay, xy is the small... xy is bounded above by 1. So, like, what if I just say, like, because 2 root x squared plus 3, y squared plus 3, can you use x plus y equals 2? Yeah. Well, I'm about to do something, so I'm going to just use Cauchy straight on this as x squared plus 1 plus 1 plus 1. And then 1 plus y squared plus 1 plus 1. Yeah, and the suggestion is I'm basically going to try to get it so it's only xy, and because xy is small, the things work the way I want it to. So, because this is at least x plus y plus 1 plus 1, which is equal to 4, so this is the first time I'm actually applying an inequality, so the result might not be true after this. So I want to save my work up to now, and then just write this. Because it's at least equal to 4, then I only need to subtract, and only need root 4xy plus 12 is at least 4, 8, 7 plus xy. Okay, and this is an inequality in... Hey, that's not supposed to happen. It's supposed to be true after I do this. Alright, what did I do? So it's like 21 plus 3xy. Yeah. What did I mess up? God, freaking. When I add 2xy, that's 4, right? So when I plug in x plus y equals 1, this is 32. This is 8 plus... Oh, I just suck at... okay, whatever. Let's not do the thing I was doing anyways. So this is 12. And so I want 12 times square root xy plus 3 to be thing. And because I have a lower bound on xy is at most 1, this is probably just true for xy at most 1, right? So it's a quadratic, so let's let r equals xy. So we want 12 times root r plus 3 is at least 7 plus r, which is true if and only if. 144. Hang on, the inequality is still flipped. This is 4. 4, so 16 r plus 3 is at least r squared plus 14 r plus 49. So we cross our fingers that this is true for all r at most 1, and I hope it is. So this is true if and only if 0 is at least r squared minus 2r plus 1. That's not good. Is it actually flipped? Oh no. Are you kidding me? You're telling me this inequality is true for every is flipped for every xy. Really? Am I that unlucky? I thought at worst it would be like, it's true for some values of r, not... Oh no. Why did that happen? It shouldn't... What? I feel like that's unusually unlucky unless there's something else going on. Is there another equality case? Is like 0 to an equality case? No, it's not. I thought this would be true for small r, because r is less than or equal to 1, but it's r minus 1 all squared. Okay, so this is... meh. Worth a shot. Dang it. Unlucky. I'm surprised though. That's really not what I expected to happen. Like I thought this would be, maybe it would be false, but it would be false for like some values of r, but this is false for every value of r. Dang it. Alright. Okay, is there another thing that I can do that won't take too much time? You know, there's a balance between, I could just, you know, keep squaring both sides until I get something that has to be true. But obviously I want to save work and like cross my fingers that, you know, things don't end up too bad. Like, you know, you try something like this, and if it solves the problem, you're happy, and if not, it didn't take too much time. Anyways, someone's saying that I should expand x squared plus 3 times y squared plus 3, so I will just do that and follow that suggestion, because that looks like a pretty good suggestion. x squared, y squared, and then plus x squared plus, so 3x squared plus y squared plus 9. And 3x squared plus y squared plus 9. We know this is 4 minus 2xy. So x squared plus y squared minus 6xy plus 21. Oh, so now it's one variable again. Okay, yeah, so we get, okay, I didn't need to do the stupid thing to make it a one variable inequality. Great. So what do I do now? Just square both sides. I don't want to square both sides. Can I do like some Kochi garbage or something? But the problem is the square roots are going the wrong way, right? Like, yeah, like sums of square roots are not great. So anyways, I have a one variable inequality I need to prove is true for t at most 1. Are they gonna make me square it? Like I could square another 2 times, but that seems terrible. Is there just no better way to do this? This gotta be, right? What if here, instead of like this thing, I do it where it's like xy plus 3? If I say this is at least t plus 3, is that good enough? Let me quickly try that, because if it works, it'll be cleaner. Because I can square and solve the problem, but it's gonna take me a while, and I really want to. I guess if it was a competition, maybe I'd square. Maybe I wouldn't. I think you try the things. I think you should try like 2 or 3 things that will each take like 5 minutes, and if none of them work, then you can really spend half an hour and like square your life away. It may not. I don't know how long it would take actually. I don't have a good sense of this. But is it true that is this inequality too? It's just 12 square root 2 t plus 3 plus twice t plus 3. Less than or equal to 29 plus 3t. For t less than or equal to 1. So this time I want 12 root t plus 3 is less than or equal to 23 plus t. So square both sides. Oh shoot. T squared plus 46t plus 529 is against 144t plus 432. So this is true if and only if. This might work. It works with like, I think like quote unquote. I expect this kind of thing to work about half the time. T squared minus 108t plus 97? Something's wrong. 98 equals t minus 1, t minus 97. Okay, did it flip? Ugh. Dang it. I'm really getting unlucky with this. Okay, they both didn't work. Really? Can I just don't want to square. Can I not square? Is it really gonna make me square everything? Already squared once. That's already bad enough. Why make me square again? It's probably not that bad. You have very generous definitions of not that bad. Alright, let t equals xy. So on 12 root t plus 3 plus 2 times the root of t squared minus 60 plus 21, at least 29 plus 3t for t at least at most 1. Okay, I'll square it, I'll square it, I'll square it. Okay, so squaring both sides. I got 144 t plus 3 plus 4 t squared minus 6t plus 21 plus 24 times the square root of t squared minus 60 plus 21 t plus 3. Derivative might work. I had the same thought, and I think that's even worse than squaring. So 9t squared plus 87 times 2 is 174t. And I could probably crash because I missed a print or something. And then 29 squared is 841. So yeah, I'm actually squaring it because I can't figure. I tried some nice things and they all didn't work. So what am I supposed to do? Okay, so let's collect the terms. On the left hand side, we have 24 times the square root of. Okay, let me put this in a new display. 24. Okay, and then what's the against? So the t squared coefficient is 5t squared. The t coefficient on the left hand side is equal to 120, and we're subtracting that from 74. So that's plus 54t, and 841 minus 84 minus 432 is 325. And we debug our work by plugging in t equals 1 and making sure it's still equality, which I hope it is. 16 times 4, so this is 892, and at 384, am I up by a factor of 2? I forgot the 2 here. This is 48. Okay, so now I just square again. 2,304 times t squared minus 6t plus 21t plus 3 against 25t to the 4 plus 540t cubed plus 1,625, 3,250t squared for that, and then there's a cross term of 2,916. So this is 6166, and then 54 times 325 is equal to 17,500. I hope. No, that's not right. So that's not 17,550. My bad. And then 325 squared is some abomination. So when you were telling me this is not that bad, were you just saying that to bait me? I can't even debug this anymore. Like this is like I'm trying to plug in t equals 1 and I'm like not fast enough to. I want to debug it term by term. 16. Yeah, okay. That right hand side I think is correct. Okay. The right hand side is equal to some other thing, which I now have to full expand. I thought you guys were big. I was like, it's not going to be clean. And people are like, no, it's fine. Okay, so the inside stuff I can do by hand. It's t cubed minus 3t squared plus 3t plus 63. And this I can debug by plugging in t equals 1. That's fine. So now the left hand side is that, and then 6,912t squared plus 6,912t plus, oh my lord, 12, 18, 24, 6, 145,152. Most people are not this. So for people that don't know, when I was a little kid, is this oh yeah, I forgot to write the t. Yes, there's a t there. When I was a little kid, between when I was like in 3rd grade and when I was in like 9th or 10th grade, I spent like a couple hours every week-ish, maybe less, maybe more, quite a bit of time playing with this thing. And when you learn to use this thing, you can just do calculations like this in your head because you don't need the physical device once you have it in muscle memory. Like the reason this thing is so efficient is because if you're doing an n by n calculation, you only need O of n's memory. Because when when you do it in the American schools, right? They ask you to do like n squared partial sums, or like it has to do partial sums. So you need like n squared memory before you do it all. But when you encode the muscle memory such that you can add it onto the register, then you only need all of n memory, and that's why it's so much more efficient. On top of the fact that you're also using muscle memory. Yeah, it's very efficient. It's much better than. If you care about being good at arithmetic, this is just much better than whatever the Americans use. Okay, cool. So, yeah. Okay, let's subtract now. So 540 minus 2,304 is minus 1,764. Where can one learn this? Honestly, I'm not totally sure. Also, I've screwed up. It's, like, you kind of just. There isn't a trick to it. You just do it until you're used to it. I went to like private lessons when I was really small because when I was 8 years old I was really dumb. Well, okay, maybe I wasn't that dumb for an 8-year-old. I like to think I was like a relatively smart 8-year-old. Unclear whether that's true or not. Okay, 39937 I think is this coefficient, minus. 8-year-olds are dumb, period. That sounds about right. 39527. No. Is that correct? Okay. Alright, good night. See ya. 8-year-olds, yeah. So, the only memory I have from when I was 8 is, oh my god, t equals 1 doesn't satisfy, so I screwed something up. I wish I had saved the thing before I multiplied by 2,304. 63. That looks correct. Did I flip a sign or something? Why isn't it checking out? It shouldn't be off by this much unless I made some really egregious error. Like it's not off by like just some nice number. Is it worth to learn? I think you can pick it up as a hobby. I think it doesn't seriously help for any math competition related purposes though. 3,804 is the... So both sides are equal to 3,804 in this line. So after I square it, both sides should be on the order of like 10 million when I plug in t equals 1. So why didn't that happen here? 384. Oh, that's because this is not 48, is it? Alright, what is it supposed to be? 16 times 4, 8, 380. No, 384 is fine. Did I mess up the expansion or something? This is 3t, right? And then this is minus 3. Yeah, I don't know. 63. This is where most of the weight comes from. Most of the weight should be this term. What did I miss? What did I screw up? Like, why isn't this simplifying to what I need when... $16 times 4 is 64, 8, 8. Yeah, no, this is... what? Why are they so far off? Like, this is 10, 10... Like, I feel like there's a place where I subtracted rather than adding or something, but I don't see it. But there's no way the errors are that big. Yeah, t equals 1 is not a root, so something's wrong, and I can't figure out where it went wrong. Like, t equals 1 is still a root here, and when I... something's really strange. Did I just miscompute the... So, 384 squared, like, is this about 384 squared when I add it? It's like about 10,000, right? This is the main term. This is why I didn't want to square both sides, because I don't trust myself to do this sort of thing anymore. Well, what did I mess up? Like, okay, like, didn't I multiply 17,750 by 2? You didn't multiply 7,750 by 2. Oh, are you serious? God. This is why, okay. At least it wasn't arithmetic there. I was like, I should double check all the arithmetic. Okay. 360. Did I also miscompute it? 35100. Okay, well, that makes more sense. So 2818. Okay, cool. So t equals 1 is a root now, and now we can start factoring it. So 25. So t minus 1 times 25t cubed, and then minus 1764 is minus 1739t squared, and then 1339t squared, or no, 11339, right? So what am I? How does this algorithm go? I just keep subtracting. 26849. No, sorry, 16849. No, that's definitely wrong. 11649t. That's not good. Okay, how do the signs work? How do you divide by t minus 1? Minus 11339. So this one should be plus. Oh, actually, I know what it's supposed to come out. It's supposed to come out to plus 39527. Yeah, which it does. Okay, cool. So what happens when t is about close to 1 here? Is it a double root? It might be a double root just given how sharp I've seen the inequality. No. This has got to be positive, right? Because t is less than or equal to 1. Yeah, okay, this is just positive, right? Did I flip any signs? I don't think I did. This is t coefficient of plus. Yeah, is that it? Is that it? I think we're done, right? Because this thing is just always non-negative. Alright. Yeah. You guys really made me square both sides. What do you mean it wasn't that bad? Those numbers are 6 digits long. Here's the ALPS thread. Okay, what did I miss? I want to see what the actual solution was supposed to be. I can't believe this is the ALPS thread too. Okay, I don't see a nice solution. Do you guys want to write this solution up and post it? I think it will be funny. Let's do it. Alright, okay. Okay, so what do I call this? AMSP... I'm just gonna use this as the... Oh, whatever. Oops, shit. Okay. Okay, so I'm missing IFF arrows, right? Why so bash? I mean, you saw me try to find an easy way out and not find it. Okay. You know, I think I'm gonna record this in my database under a Twitch identifier. And I'll make a note AMSP Alg3.5 algebra. This is inequality. Grinding. I don't know what to tag it. I'm not sure what to say other than I expanded. Alright, whatever. Tricky unique? But there's not even a trick, you just expand. Like, I thought there would be something and I couldn't find it, and you know, what oh, anyways. Solution from Twitch solves ISO. That's not a trick! That's just sad. Post 6 uses something nice. I don't know. It's just like... Don't you no, this is not going on equality. Like, at all. No chance. No, like, no.